So if you get a projectile question using I and J notation, okay, essentially it's using vectors, right, in 2 dimensions, where of course the I direction is representing the units in the X direction, and the J then vector represents the number of units in the Y direction, so the horizontal there, vertical there. And by using I and J, it makes the problem much more straightforward, okay? All right, so you need to appreciate if the initial velocity here, it says in the question, because it says the particle is projected, isn't it, from the origin at a velocity of 4i plus 11j. Okay, so this is initial velocity. You just need to appreciate that means it's essentially 4 in the x direction and 11 meters per second in the y direction. Okay, so if we were to go down the route of setting out our equations horizontally and vertically, okay, you would say, look, ux is equal to 4 and uy is equal to 11. Okay, so the initial velocity horizontally is 4, initial velocity vertically is 11. Okay, but we don't need to go down that route. Okay, we can keep it in terms of vectors, and it makes the situation there much more straightforward rather than stripping it down and looking at horizontally, vertically as we normally do. Okay, we can keep it in terms of I and J's, okay, and go straight for using the formulae. But a couple of things to note, all right? Horizontally, of course, remember the acceleration is 0, okay, because there's no acceleration, isn't there, when that particle is moving freely, okay? Horizontally, there's no acceleration, but vertically, of course, there is, isn't there? Remember, acceleration, well, it's due to gravity, isn't it? And gravity acts downwards. So if we're taking upwards as positive with our axis system here, then we've got minus g here, haven't we? Okay, which will be, of course, minus 9.8. All right, so that's when you strip it down in horizontal and vertical. But if you, of course, go back to the vector form, we could say, look, the initial velocity u is 4i plus 11j. Okay, so remember to underline your vectors. Okay, so that's the initial velocity u. And my acceleration, okay, of the particle, well, it's 0i, isn't it? Okay, there's no i. Okay, it's not accelerating horizontally, but we've got minus 9.8 then j. Okay, so the acceleration is just minus 9.8 j. So then it says find the position vector when t is 3. So we can say, look, when t is equal to 3 seconds, okay, we can use s equals ut plus half at squared, as we normally do. Just remember to underline, that's all, the vector quantities. So underline the displacement, okay, because it's got position, isn't it? It's got direction and distance, the initial velocity and the acceleration, okay. Don't underline time, because time is just a scalar quantity, it's just a size, isn't it? Okay, so using this formula, okay, we can find out where its position vector is. Okay, so you've got u, which was 4i plus 11j, times t, which is 3 seconds, plus then half. Well, acceleration is due to gravity, which is minus 9.8j, and then you've got 3 squared then for t squared. Okay, so we can then expand that first bracket there, so you get 12i plus 33j. Okay, and then a bit of maths here then, obviously you've got half 0.5 times 9.8 times 3 squared. So when I times them together, I get 44.1. Obviously it's a minus, yeah? It's a minus there. And then just bring that together then. So we've got 12i and then 33, take away 44.1, so you get minus 11.1j. So that's where it is. And in fact then, what's actually happened here is, after 3 seconds, is it's been projected up like that, and actually it's gone underneath, isn't it? Okay, so maybe it's been projected from the top of a cliff or something, because after 3 seconds it's got a minus component there for the j, so it's in the negative region of the y-axis, so it's down there somewhere, from maybe falling to the sea or whatever. Okay, so this is position vector, and that's what they're asked for, remember. Okay, if they asked for the distance, okay, well, you've got the position vector, okay, but you need to get the distance, then you need to use Pythagoras, don't forget, yeah, to get the actual distance. To get the velocity vector, then we'll just use this then, yeah? V equals u plus at. Okay, so as we normally do with projectiles, so v will equal to u, which is 4.8 plus 11, sorry, 4I plus 11j, plus then the acceleration, which is minus 9.8j, times then the time, which is 3. So we've got 4I plus 11j, and then 9.8 times 3 is 29.4j. So then my velocity, okay, will be minus 18.4j there. So 4I minus 18.4j